Good afternoon, everyone. My name is Rashmit Singh Sukhmani. I'm a CTO and co-founder of SatSure. Who we are? SatSure is a global deep tech company that provides decision intelligence from space, where we leverage advances in satellite remote sensing, machine learning, deep learning, and cloud technology to provide smart decision-making framework to an enterprises. So what are we trying to do using Earth observation data and its analytics? When we started this company, as in we all coming from the space tech background, we did our undergrad in the ecosystem of ISRO. We understood what potential that space tech can provide and impact that it can provide on our society. And that is where the first complex problem we always wanted to solve was in agriculture domain. But being a small team, how can you create an impact for a farmer? That was the one thing. But then later on, we understood that yes, being a small team, you cannot work with individual farmers. But how can you improve the ecosystem there? But the major problem with agriculture was that data was difficult, as in there is no common repository. The data is in multi-language, I would say, not coming from the similar ecosystem where we can build models on top of it, what you see generally in the developed nation. And it's expensive. You need to send people on ground. It's time consuming, and you cannot rely on that data because that's being collected by manually, as well as the reliability is less on that. So that is where there are three different products. One is your SatSure Sparta, Sage, and Skype. But briefly, I'll be touching on each of the data products. But SatSure Sparta technically is your data engine where we churn out huge amount of data, especially on the remote sensing front, that could be directly utilized in agriculture insights, starting from, if I look at the crop monitoring, starting from sowing estimation to where the sowing is happening, what rate the sowing is happening, what kind of crops are grown, how much will be the yield of that, and where the harvesting is happening, or if there is a damage that is happening during the season, can you provide that as an insight? But when we started working with banks, none of the folks had good understanding of how geospatial technology can be utilized in their ecosystem, and as well as making those decisions based on that data. So we understood in our later stage, probably 2 years after starting the company, that you cannot just be a geospatial company at the end of the day. You need to leverage the advances in data science domain as well as the software domain. So right now, if I can tell you that we are working at a juncture of all these three together so that we can also do that last mile connect, create an ecosystem where people can directly ingest the data as a decision intelligence in the decision making framework. So if I briefly want to touch about Sage, Sage is a banking solution. So which helps banks to better improved, I would say, an accurate assessment of a farm while making lending decision to a farmer. In today's world, most of the credit manager highly rely on your credit score. And most of the farmer doesn't have a credit score. That means then they do not have access to the credit if they want to grow some crops, which is probably a cash crop to generate a revenue there. That is why we provide capacity score on a farm level, which banks use it in conjunction with your credit score. Now, along with that, once the banking solution is done, and if I talk about the Sparta, which I told you, where we have created a digital twin, as in when I spoke about starting from your sowing, harvesting, what type of crop it is, you can literally create that digital twin using a Earth observation data. And that is why we monitor in terms of what is happening on the ground at a pixel level. Right now, we have a presence and in more than 480 districts in India, covering around 8 states, where we are providing all the basic data products, starting from farm boundary, crop classification, health, crop performance, damage assessment, and harvest. Reason to do that, see, being a smaller team, we will not be able to tap into every use case that individual want, especially in the agriculture sector. There will be a number of use cases what people are trying to do as of now, and this is where we thought, can we create that open data platform where people can come build their application using the data, especially which is remote sensing data, which is, I would say, highly, you need better understanding because the information density when it comes to the satellite data is much higher. It's not like your natural imagery. And to do that, you need to have, top of that, the computational capability that you need to have at your end. So if I talk, the Sparta technically is the open data platform where it provides your API as well as which can be connected to any application, whether what enterprises wants to build on. And top of that, it also provides a dashboard view in terms of sowing, harvest, all the basic layers. There's something interesting. This is not something that we provided to the client, but this is the need that came when we were not able to meet our SLAs at the end of the day, because we are known for giving timely information to our customers. But in India, the basic challenge would be during your Kharif, which is your monsoon season. So the challenges of optical data is that it does not penetrate the cloud cover. What that basically means is you're not able to see any features what are below the cloud cover. And this is where we had to find an innovative solution. People are talking about GANs and all generative technology, right? And this is where we leverage that technology to remove the cloud cover and do the domain transfer from microwave to optical domain. What that basically means, you're reconstructing the similar features in the electromagnetic spectrum starting from red, green, blue, NIR, shortwave infrared, which is essential bands to identify the stress, identify type of crops, identify the complete phenology of a cropping cycle in a region. So just an example, it's a GIF. What you see on the left-hand side is an actual imagery. What you see on the right-hand side, it's your false color composite. You just have to change the band color. But what you see on the red, right, that's your vegetation. But if you look at on the left-hand side, after changing the GIF, you have high cloud cover in a region. That means I cannot provide any insights on top of it. But after doing that domain transfer, we were able to essentially recreate that same optical domain data, which is essential for any analyst to identify what feature is under the cloud cover as well as work on it. So this is just another example which we provide using SatSure Sparta. Now the other domain which is at a nation stage, I would say, where we are able to find PMF for one or two use cases as of now. But yes, we started with agriculture, but we are not an ag-tech company. We are a full-stack Earth observation company at the end of the day, where we provide intelligence and better smart decision-making tools to our clients. But similar sort of learning what we had in agriculture, now we are including that into infrastructure management. So these are some of the things that we do, especially when it comes to infrastructure management, starting from your airports, renewable energy, asset monitoring, oil and gas. But this is one of the PMF. The biggest challenge for any high transmission power line companies was that for cost of survey for 1 square kilometer of region would cost them around 11,000 rupees approximately. And top of that, if they want to do a survey for, let's say, 100 kilometers, 200 kilometers, it used to generally take 45 to 60 days for them to do it. And top of that, the reliability of that information was not there because they had to send people on ground. They could not cover the complete area, so the data was dubious, and they cannot rely on it. That is why we came up with a solution using a satellite data technology where we are providing them the information by looking at underlying features at an automated basis and giving all the information which is relevant for them before the tendering process in probably 1 or 2 weeks. So you're reducing that time and reducing the operational cost. And this is another damage assessment which we are doing generally with our insurance companies, where they want to understand what was the situation before the event that has happened and what was the quantum of damage that has happened after the event. For example, your floods, cyclones, any other hazard. And this is just an extension of the high transmission line, where one solution was catering to the tendering process to provide them the low-cost solution. The next one is once your power line is established, let's say, But still they have to do the manual survey in terms of identifying the risks around the vegetation which is growing around the transmission line, right? And this is where we are providing the solution where we are giving them the timely triggers where the risk could be for the vegetation or any other calamity that is happening, and they can take preventive measures before actual damage happens. And so this is just another chain detection. This is an interesting image, I would say. See, this is just one snapshot of the imagery when you do look at the time series. Yes, if you look at this small area, you could easily see that there's some changes happening in terms of the construction. But imagine that you need to do it on 100 square kilometer of area. Or, for example, Bangalore city is around 800 square kilometer. How much time and effort will you be have to do in terms of identifying each of the every change that is happening? That is why this is where your data science technology as well as your engineering stack as well as your geospatial understanding comes into picture, where you're solving the issue at a pixel level. And right now, what the image that you see is 1 meter resolution, by the way. So during our whole journey in SatSure, we highly relied on open source data, especially when it comes to the agriculture and any other things or the use case that we solved in agriculture sector, starting from your banking, insurance, that way. But when it comes to the infrastructure domain, you cannot use the existing open source data, right? Because the limitation would be on the resolution of the information. 10-meter resolution will not cut it out here. Reason being, people want better information at a much more granular level. But the challenge right now in the Earth observation industry is that there is a monopoly that's happening at a global level. For example, you might have heard about Airbus, Planet, that way, right? And the prices are not going down for the commercial. For example, if I want to get 50 centimeter data, right? That generally will cost me around $40 to $45 per square kilometer. Now, if I want to monitor a larger region, yes, technologically everything is feasible, but there's no business viability. There is no business innovation that you could do. And this is where we thought, like, having that dependency on the third-party vendor, why can't we control the upstream side ourselves? Right? And this is where we started ideating about it in 2019, that you need to have your own payload providing the similar set of data and to tackle all the issues. But if you look at the current landscape, you might have heard about Cartosat, right? Which is your defense payload, and it's not commercially available as such. And you cannot access that data. That means then you'll have to rely on the foreign vendors to get that data. So what we thought, like, looking at our own use cases, how can we cater that, meet our SLAs that way? And this is where we designed our own specification. And so if I talk about the specification, our own payload, that would be 4 microsatellites at 370 kilometer altitude, having AI on the edge. Yes, people have been talking about IoT sensors that way. Satellite is also one type of IoT sensor at the end of the day. And the time it takes to download that information once the image is captured, it's huge. And there is an operational cost around it. That is why we thought to improve the cadence of information that you could provide to your customers, you can have that AI on edge where your algorithms can run once the image is captured and only output could be downloaded. Just to give you a better context, for 1 meter resolution, let's say if I'm covering around 25 to 30 square kilometer of area, the size of that image would be around 4 to 5 GB, one single timestamp. And if I run my algorithm on the edge itself, I'm reducing that whole size of that information by 100 times in MBs technically, 10 MB, 20 MB that way. So this is just a edge data processing, just to give you a better idea what we are doing. And we tested our algorithm, by the way. We became India's first company to demonstrate that on edge, thanks to our Australian vendor, where they had their own payload as in terms of imager as well as the AI processor. And we tested our road network detection there, and on ground, especially on the cloud, to churn around 10 to 15 GB of data, it used to take 40 minutes to 50 minutes. We were able to bring that down by to 1.5 minutes, and the same scale. That was one of the important milestones because everybody was talking about edge on the space, but is it actually feasible or not, looking at the scenarios that you may encounter, because nobody can predict that, whether there will be a solar flare or sensor may go wrong or something, but can your algorithm be robust enough to identify all those features and the use case that you're trying to solve? And the other one, we are tested on the virtual environment, which is space qualified, and we were able to get the result, but the road network, we actually, that was the interesting one because when we tested it out, it was on 20 square kilometer of area, but the actual image that was captured was around 500 square kilometer. That's a huge image at 1 meter resolution having 5 bands in it. And that is why the time was an important benchmark for us. We were able to reduce it by 100 times and technically to 1.5 to 2 minutes. In our journey, we were able to create an impact, especially on the agriculture front, where our solution has provided like 4 million farmers were able to get loan using a SatSure Sage product. 400,000 claims were settled, 1,200 civilians, because we also do some of the ad hoc work in terms of the natural calamity, helping the government in terms of where the flood has happened, what's the risk, etc. Along our way, not just on the geospatial front, but especially on the data science engineering stack, we were able to file 4 patents in our journey. And these are some of the recognition where we start. Our first recognition was with Bill and Melinda Gates. That's how we started our journey. That was in 2017. But till now, being a co-member of World Economic Forum, having ADB as our investors as well, and rest, what you can see, being a top 20 global companies here. So this is what it is, and this is who we are, and hope to do a lot of innovation in this domain, because I would say we were just able to touch the surface as of now, but we still have to go a long way. So thank you, nasscom, for inviting me here. Thank you.
For more content on tech and leadership, subscribe to nasscom YouTube channel and press the bell icon to never miss an update.